Electromagnetic interferences is considered one of the serious disturbances generated by the external source that affects wireless signals and systems by electromagnetic induction, electrostatic coupling, or some electromagnetic conduction. In this unit, we will discuss the effect of electromagnetic interferences on wireless communication system. We will discuss detail about the EMI compliances and standards. It play a very vital role for the design of wireless communication transmitter and receivers. And then finally, we discuss about EMI reduction, that how we reduce the electromagnetic interferences as much as possible for a smooth and efficient wireless communication system. Electromagnetic interferences can have various effects on wireless communication system, which ultimately leads to degrade the performance and reduce the reliability of wireless communication. Here are some common effects of EMI on wireless system are reported here. The most important is signal degradation. EMI can cause signal degrading in wireless communication system. The interference can introduce electromagnetic noise, distort the signal waveform, and reduce the signal to noise ratio. As a result, the received signal quality is very seriously deteriorates and leading to decreased efficiency and increased bit error rate, decreased data rates, and reduce overall system performance. Similarly, it also increased the error rate. EMI can introduce error rates in wireless communication systems. The interference can corrupt the transmitting data, causing some bit errors or packet loss. Increasing Increased error rates can lead to retransmission or reduced throughput and lower reliability in wireless communication. Similarly, the range reduction is very serious issue for modern mobile system or cellular system. EMI can limit the effective range of wireless communication. Interference can weak or block the desired signal, making it challenging for receiver to detect and decode the actual signal accurately. As a result, the coverage area of wireless network may be reduced and limiting the communication range between transmitter and receiver. Connecting is another serious issue. Interference from EMI can cause connectivity issues in wireless communication. It can disrupt the establishment and maintenance of wireless connection, leading to intermittent or unstable connections. User may experience some dropped signal, some interrupted data transfer, or frequent disconnection due to due to the presence of electromagnetic interferences. And similarly, the reduced signal penetration, EMI can reduce the ability of the wireless signal to penetrate obstacle and propagate through the environment. Interference can attenuate the signal strength, making it more susceptible to blockage or by physical barrier such as walls, building, or vegetation. This reduction in signal penetration can result in coverage gap and limit indoor or obstructed area connectivity. Performance interferences with correlated echo-located systems. In scenarios where multiple wireless systems operate in proximity, EMI can interfere with co-located systems, and the interference can impact the performance of neighboring wireless network, causing some crosstalk, channel interferences, and reduced throughput for all systems involved. And finally, unreliable communication. EMI can make wireless communication really unreliable in certain situations. It's sometimes unpredictable. Interference can introduce intermittent disturbances, signal fluctuation, and sudden dropout, leading to an unpredictable communication. This unreliability can hinder critical application, and service that require consistent and dependable wireless connectivity. Regulatory standards for electromagnetic interferences vary across different countries and regions. These standards are established by regulatory bodies to ensure that electronic devices and systems must meet some specific requirements regarding their emission and susceptibility to interference. Here are some commonly recognized regulatory standards for EMI presented. The most important is the FCC, Federal Communication Commission. The FCC in the United States set some standards and regulation for EMI under the Title 47 of the Code of Federal Regulation CFR. The FCC regulates both intentional radiations, devices intentionally transmitted radio frequency, as well as unintentional radiation. Unintentional radiation means that such devices that may emit unintentional radio frequency energy. It defines limit for conducted and radiated emission for various frequency bands and equipment types. CISPR, which is International Special Committee on Radiation Interferences, the radio interferences. CISPR is a part of International Electro-Technical Commission, IEC, developed international standards for EMI. CISPR standards provide some guidelines for the measurement and limit of the conducted and radiated emission from electronic and electrical communication used in wireless and non-wireless communication. Common CISPR standards include CISPR 22 for information technology equipment and CISPR 25 for automotive electronics. Similarly, European norms, EN standards. In Europe, the European Committee for Electrotechnical Standards, EN, elect developed standard for the EMI compliances. EM standard aligned with the CISPN standard and define emission and immunity regarding for equipment or requirement for the electronic devices and system within the European Union. VCCI, which is called Voluntarily Controlled Council for Interferences by Information Technology Equipment. VCCI is a regulatory body in Japan that establish standard for EMI compliances for international technology equipment. VCCI regulates specific limit for conducted and radiated emissions based on CISPR standards and required compliances with testing for products sold in Japan. Industry specific standards. Certain industries have their own specific EMI standards. For example, the automotive industries follow ISO 11452 for electromagnetic compatibility testing for vehicle, and the medical industry compliances with IEC 60601 for medical electrical equipment. So finally, it is important to note that these are just a few examples of regulatory standards for EMI. Other countries and organizations or regions have their own specific standards and requirements. Manufacturers and designers must ensure the compliances with relevant standards to meet the regulatory requirement and ensure electromagnetic compatibility of their product in the intended market. Mitigate the electromagnetic interferences and ensure the reliable operation of electronic devices and systems. Several techniques can be employed. Here are some common EMI mitigating techniques, such as shielding. Shielding involves the use of metal enclosure or barriers to prevent the entry or escape of the electromagnetic radiation. It can be achieved through the use of conductive materials such as metal sheet or foils to create a Faraday cage around sensitive component of the devices or wireless transmitter or receivers. Shielding can block external EMI from entering the system or contain internal EMI generated by the system itself. Similarly, filtering, EMI filtering, also employed to suppress unwanted electromagnetic noise or power lines or signal lines. These filters consist of a passive component such as a capacitor, inductor, and resistor. Combination of these components that attenuate high frequency noise while allowing the desired signal or power to pass through them. Filtering can be used at the input and output of the device to reduce the conducted EMI interferences. Grounding and bonding. Proper grounding and bonding techniques are also crucial for EMI reduction. By establishing a low impedance path to ground or ground helps to divert the unwanted electromagnetic signal or even electrical current and reduce the risk of EMI. Bonding ensures that different component and enclosures are electrically connected to maintain consistent potential and minimize some ground loops that can introduce interferences. Layout and separation, careful layout design and especially for components can also help to reduce the EMI and such as power supplies, motors or high frequency devices. EMI absorbers are such material that absorb or attenuate electromagnetic energy. They are used to reduce reflection, resonance, and standing wave that can cause some interferences. EMI absorber can be placed strategically within the system or used as coating on the surface to minimize EMI. Grounding filters, grounding filter, also known as ground loop isolators, or they're used to break ground loops and eliminated unwanted noise by potential different between interconnected devices. Ground filters interrupt the ground path while maintaining the signal path, thereby reducing EMI and minimizing the noise coupling. Frequency planning and spectrum management. In wireless communication system, frequency planning and spectrum management techniques can also help to mitigate interference. By carefully allocating frequencies, avoiding congestion band, and implementing proper channel spacing, impact of co-channel and adjacent channel interferences can be minimized. Electromagnetic compatibility testing, EMC testing is, is highly practical for the wireless communication design, operation, and maintenance. This is performed to ensure compliances with regulatory standards and assess the susceptibility of the device to EMI. By subjecting device to control electromagnetic environment and analyzing the performance, potential EMI issues can be identified and addressed during the design and development stage. These are just few examples for EMI mitigation technique. The specific technique employed depends on the nature of the EMI, the characteristic of the system, and the application standards or regulation. Implementing a combination of these techniques can help to minimize EMI and maintain the proper functioning of the electromagnetic devices and system.